HNMR spectrum. So the point of an HNMR spectrum is to identify an unknown sample or substance. You create a product in lab. The HNMR it's a machine. You'll put a little on like a tray in a lab, and the computer will read it, and it will give you this graph. And on the graph, there's three important things that you need to know: the chemical shift, the integration number, the splitting. I forgot what G there. Splitting pattern. So chemical shift is what kind of hydrogen it's going to be. Because we're looking at hydrogen atoms. So, like, what kind of group is it? Is it a methyl hydrogen, or is it a hydrogen that off of an oxygen created to an alcohol, or is it a carboxylic acid hydrogen? Or anything else like that. The integration number is going to be, you're going to have your signals on the graph. The integration number is exactly how many hydrogens. Well, actually, the integration number is a ratio, but generally that's going to tell you how many hydrogens are on each signal, and then the splitting pattern is n+1 is the formula for that. Splitting pattern is how many hydrogens are next to the current one that we are looking at, that signal. So let's go ahead and start. We're going to start with an example where we are given the molecule and asked to draw the HNMR spectrum. I think it's a little easier to begin learning it this way. So for this propanoic acid, we know there's two implied hydrogens there, and then this is a methyl group off of the end. There would be 3 hydrogens there, C and 3 hydrogens, just as there's a carbon there. So how many signals is that going to be? Well, we know this is in its own unique chemical environment. So are these two. It's B, and then so are those. Those are all unique environments, 3 signals. So there are going to be 3 peaks on this graph over here that we're about to draw on. So let's just start with peak A. Let's go ahead and write out everything we know. So in looking at this peak A, you got to recognize the functional groups first. We can see that this whole functional group here is a carboxylic acid functional group. So you look on your chart. That's either in your textbook, or you can just Google HNMR chart, and it's going to give you all the proton chemical shifts. You can probably use any of them, but so you look on there, you just identify your group, what kind of hydrogen it is, and for this you'd see a carboxylic acid is, it's really from about 10 to 12 is where you're going to see those. So there's our chemical shift, and now the integration number. How many hydrogens is it? So on that peak, well, we can see there's only 1 hydrogen right here, so the integration number would be 1. And then the splitting pattern, how many hydrogens are next to it? And our formula is n+1. So we're just going to look to the atom next to it. If there's 2 atoms, you look at both of them. This one, there's only this carbon right here, and look at that, there's no hydrogens on it. So our n would be 0 because there's no hydrogens, and then you add 1. 0 plus 1 would equal 1. So that would give us what we call a singlet. Okay, so let's go ahead and draw that one on there. So anywhere between 10 to 12, we'll just draw it right at 11, there's going to be a singlet. Let me do it in a different color, just to give us some contrast here. There we go, singlet, just 1 peak, just like that. The integration number is 1. Usually the integration numbers are up top. Sometimes they're down below, down here. But yeah, either one. And a lot of times they're decimals, because like I said, it is a ratio. You kind of have to figure that out. I'll show you the ratio at the end. I'll try to explain that a little more. But okay, for now, let's just go and look at signal B. Okay, signal B. So what do we have here? It is 2 hydrogens. Our integration number would, let me put this, would be 2. We know that. The chemical shift, so what is it? It's next to a carboxylic acid group. Now this, alcohol over here is actually, it's not going to affect it too much. The main thing we're looking at is the carbonyl group. So if you find on your chart 2 hydrogens next to this carbonyl group, I mean, you may have a chart that has it next to a carboxylic acid group, but your chart may only have hydrogens next to a carbonyl group. So that would, so then you just use that one, and that chemical shift would be, it should be around 2 to 3. It's going to show up somewhere around there, and then what is our splitting pattern? So remember, we look at any atoms next to it. So we have this atom and this one. We already know there's 0 there. Then on this one over here, there's 3. So 3 hydrogens plus 1 gives us our splitting. That equals 4. 4 is a quartet. And let's go ahead and draw that on our graph now as well. Okay, so at somewhere between 2 to 3, we're going to have a quartet. So 1, 2, 3, 4. It's going to look something like that. Oh, and then our integration number would be 2. Roughly a 2 showing up there. Okay, so for the last one, we have, CH3, a methyl group over here hanging on the end. It's next to another carbon with 2 hydrogens. We can look at our chart and, well, it's probably just going to show a methyl group approximately at 1. Would be our chemical shift. And then, let's see the integration number. We have 3 hydrogens, 1, 2, 3. Integration number would be 3. And then the splitting pattern would be, okay, what are we next to? We're next to this CH2, so there's 2 hydrogens. Splitting pattern would be 2 plus 1, which equals 3, which would be a triplet. Hope you guys can read that, but okay. So we're going to have a triplet at approximately 1, 1, 2, 3. And the integration number for that is 3. So that's what our HNMR spectrum would look like for propanonic acid. Okay, so, and one last thing. Let's go ahead and draw. There's this thing called a TMS signal here. That's just, it's a little substance that you'll put in, it's a chemical you'll put in with your sample. It's just always going to show a peak at 0, and that just kind of serves as a reference point to give you this whole ppm numbers here. It is all that's really going to do. Sometimes you'll be asked to label that. But okay, let's move on. Okay, so now we are given our HNMR spectrum, and we're asked to draw the molecule for it. This is a little more realistic in lab. Because it's an unknown molecule, you don't know what the structure is. But let's just start out with, let's start with everything that we know, and just write it out for each peak. Okay, so for this first peak here, what do we know? So it's a triplet, or we can see right away it's at approximately 1. Approximately 1 would be the chemical shift, so we know that tends to be a CH3 group. It has a integration number of 3, so yeah, it's probably going to be a CH3 group. And then the splitting pattern was a triplet. So we can go and write out, let's just CH3 group, because we know there's probably CH3 there. Okay, this next one. Now this one's a little harder. We have a singlet. Let me just label these A, B, and C, just so I can draw. Over here we have more space. This is A. Okay, so B, we'll draw it over here. We have a singlet. Just writing out what we know here. So we know that it is next to no hydrogens, because a singlet is n plus 1, which would be, 0 plus 1 equals 1. So we know that next to it there are no hydrogens. It has 3 hydrogens are on this signal. Its integration number is 3. So what has 3 hydrogens? It's probably a methyl group again. But, clearly it's not just next to another carbon, or else it would be shown up at approximately 1, and, as the same signal here. But anyways, and what else? The chemical shift. So we're at about 2, approximately 2 is our chemical shift. Okay, so like I said, we're thinking it's a CH3, just because we know there's 3 hydrogens on there. That would make sense. Let's go and do the next one though, because we just want to make sure we have an idea of this whole molecule. Okay, so right off the bat, the chemical shift is at approximately 2.5-ish in that 2 area there. We have our integration number is 2, and then it is a quartet. So we know since quartet that it is next to, that would be 3 plus 1 is how we'd have to get that, which equals 4. So we know that it is next to 3 hydrogens. So in other words, it's next to, most likely, according to what we have here, CH3. So let's go ahead and start trying to draw this molecule. So we have CH3 at one end here. We know we have another CH3, and we know that that has to be at the other end if there's another CH3. You could do something like that. And now, okay, let's focus on the signal B over here. Let's just say this one was B. So we know it's a singlet, so it's not next to any hydrogens. So what could that be? Generally, the singlets are, it could be a carbonyl group like that. It could be 2 bromines or something attached to a carbon, like just anything with no hydrogens on it. So how to figure that out, you would look at your chemical shift. We're looking right at about 2.1, somewhere around there, and we're going to see that is, you look on your chart, what shows up at 2.1, what kind of hydrogen. It's going to be a hydrogen that's next to a carbonyl group. So it's safe to say we could draw this carbonyl group as I had already drawn there. Okay, so this molecule is looking more complete. We could say that this was oops, I drew this as A. It's not supposed to be A, I'm sorry. That is supposed to be C, isn't it? Yes, sorry. Okay, so let's go and look at this one, C. It's a quartet, so it's next to a CH3. Okay, so that could work right here next to this one. This one over here. It's only 2 hydrogens, and so at about 2.5. Okay, 2.5. That's still roughly within our range of next to a carbonyl group, just like this. So it would be safe to assume that it could be a CH2 group, and that would satisfy our integration number. It's next to the CH3 for the quartet, and it's shown up at the right chemical shift. So that's the way I like to go and address these kind of problems. Just kind of start writing down everything you know for each signal, and start kind of constructing the molecule. It takes a little bit of critical thinking, but if you write everything out that you should be able to get, at least a ballpark. You should be able to get the right answer, or hopefully at least just get